Question 1. If y of x satisfies the initial value problem, y prime equals x over x squared, or the x over the square root of x squared plus 5, and y of 2 is equal to 2, then y of 0 is equal to blank. Okay, immediately when you see these initial value problems, what I like to do is I like to rewrite y prime into dy dx. Okay, and it might not be super helpful here, but in other problems, it helps to, organize it using this step. Okay, so let's rewrite this as dy over dx equals x over the square root of x squared plus 5. If we multiply both sides by dx, it cancels on this side, and we're setting it up perfectly for integration. Okay, dy equals x over x, the square root of x squared plus 5 times dx. Okay, what we're looking for is we're looking for y of 0, right? The y of 0 is just a value that is plugged into y of x. So what we're really looking for here is y of x. And the way to find y of x is to integrate this dy value, right? Because the integral of dy is just y, right? So, but if we want to integrate on this side, we should integrate on the other side as well. Okay, this looks really tricky to integrate. Honestly, I wouldn't even know where to start if it wasn't for u substitution. And the reason you know that you should use u substitution is there is something multiplied by dx in the numerator that is 1 power less. So think of this as x to the 1. That's 1 power less than what's in the denominator, which is x squared, right? So we can use a handy u substitution. We can say that let u equal x squared plus 5. And if we differentiate both sides, then we'll get that du is equal to 2x dx. This isn't entirely matched to form right now because this is x dx, this is 2x dx, but we can remedy this issue by just dividing by 1/2. So now we have 1/2 du is equal to x dx. Great. Now let's start plugging values into this. Okay. Integral of dy is equal to, we know that x dx can be replaced by 1/2 du, so let's do that. 1/2 du, and we know that the square root of x squared plus 5, we made the substitution that u is equal to x squared plus 5, so if we plug in u equals x squared plus 5 here, then we know that it is the square root of u. Okay, now let's go about integrating. Integral of dy, very easy, y of x. Okay, 1/2. We know that since this is just a constant, we can pull it out. 1/2. And to integrate something with an exponent in the denominator, I like to bring it to the top, right? This is, you can rewrite this as u to the 1/2. But if we bring it to the top, it's just u to the negative 1/2. So let's do that. U to the negative 1/2 du. Okay, to integrate these, remember to integrate something with an exponent, we add 1 to the exponent and then divide it by that value. So let's do that. So y is equal to 1/2 u to the negative 1/2. 1 added to negative 1/2 is u to the 1/2 divided by 1/2, right? Plus c. Can't forget the plus c, right? Because when you try to derive this, or when you try to differentiate it to turn it back into this form, you differentiate this, you bring down a 1/2, and then you subtract 1/2 from, or subtract 1 from it, so it becomes u to the negative 1/2, and the 1/2 that would be here if it was differentiated, it cancels out with this 1/2. So you get u to the negative 1/2 again. Okay. Something we can do real quick. There's a 1/2 on the bottom here and a 1/2 here, so we can just cancel those out. And what we're left with is y is equal to u to the 1/2 plus c. Let's plug our initial u substitution back in, and we get that y is equal to the square root. Remember, because raising something to the 1/2 is just taking the square root, x squared plus 5 plus c. Okay, we're almost there. We have this. This is called the particular solution. But now let's look for the general solution. Okay, now we can use that by using our initial condition, y of 2 is equal to 2. Okay, so we know that when the x value is equal to 2, the y value is also equal to 2. So let's replace 2 into our particular solution here. So we can say that, we can say that 2 is equal to the square root of 2 squared plus 5 plus c. If you work that out, we get that 2 is equal to the square root of 9 plus c. Square root of 9 is 3. 2 is equal to 3 plus c. Subtract 3 over, we get c is equal to -1. Now we have our constant. We can plug it back into our particular solution to find our general solution. Y is equal to, let's do y of x is equal to x squared plus 5 minus 1. That is our general solution. And now we can find what y0 is equal to by plugging in y of 0 here. Okay, y of 0 is equal to 0 squared plus 5 minus 1. And what we get is the square root of 5 minus 1. And that's option E.